I have a
Oh,
question concerning that though, Chocolate.
go.
Beyond Brenda and Rumpus, has anybody else actually gone that far?
Yeah,
Like,
loads of them. I've got them all documented. You've got an
who,
Orthodox doing it, you've got Kosho doing it, you've got AB Science doing it, you've got Simon Dan doing it. They're all doing it. They're all
oh
towing the
wow.
same exact line.
I've never enjoyed something so much. So, thank you.
I'm hooked on it also. You know, I watch my own show, as I just said, and I thoroughly enjoy watching the show. It's entertainment for me. It's not just because I'm enjoying the sound of my own voice, although that's why I'm on YouTube, right? I've got to have that kind of personality to be doing this in the first instance, and anybody who denies it is a liar, because that's why you're here.
Yeah. Yeah.
So let's add to that content. Bev, we were talking about shapes, geometry, and the Discord and some of these ballers. You want to share that?
Yeah, I'd like to add to that bit. Travis just said then that it's the brain stimulation that you get from this.
Yeah, this is the Flat Earth Armory.
Yep. That's the hook for me. The actual mental stimulation that the hearing the conversations that go on. Fantastic. But yeah, back to the geometry that they've lost, which I've been dealing with all the time, is the geometry, and you get it down to a simple level, where they don't like the simple facts that level is horizontal. It's a known fact. But now I've got it down to the fact that a perpendicular within Euclidean geometry, if you take it that geometry is how you get proofs. When they say within maths you can get proofs, you can gain proofs, well, geometry is the place that you gain them proofs, that you can prove Pythagoras' theorem. You can, there are proofs within geometry that prove themselves. So within Euclidean geometry, there is a proof that says a perpendicular line bisects another line with 4 right angles. That's what a perpendicular is. Now, they say that horizontal and vertical are perpendicular, which if they are, then geometrically they have to be parallel. There's no other way they can do it. So with the ballers losing the whatever fantasy maths that they've always had with this through the curve calculator or whatever, it's a fantastical idea, but they have to use Euclidean triangles in order to do any of their measurements, and that's proved that Euclidean geometry would prove that verticals don't intersect. It just can't, and a horizontal can't intersect within Euclidean geometry. So they're getting really upset at the fact that just asking them the question, which geometry are you using? Because I can give them a proof that it's not Euclidean geometry. Euclidean geometry would actually prove a parallel plane model. Very simple. That's how surveyors work.
It's a question that I regret not asking during the Isle of Man discussion. I don't know if you were around while that was happening.
I've heard you just sort of mention it a bit more recently, but I mean, I think it's the geometry question has been brought into the forefront through the Black Swan, hasn't it?
Precisely. It's not something that necessarily hadn't been argued about or even discussed, because we had the Black Swan image up when it was a new image and discussed it and talked about where the horizon was positioned, and we discussed the geometry at great length in the Isle of Man discussion, but we hadn't put the two together. Now the Black Swan has, as you say, pushed it right to the forefront. the failings of the geometry, the contradiction within what they claim as their geometry, if they were to ever disclose what they're actually using and how they're not using it. You know, they're not abiding by the rules of that geometry anymore. Ergo, their geometry is fundamentally broken. The model becomes untenable. But it's going to take time, and people like yourself, Bev, to point this out over and over again, as you've been doing anyway. You know, I have watched and listened to you, but again, you're discussing geometry, and you kind of take things that people say in isolation. You don't necessarily have the wider the wider picture when someone's detailing something that's specific. Do you know what I mean? Whereas the black swan is something that's widened the appeal of the geometric argument to the point where most people can understand it given enough time. And the crux of the argument is the basis of which you've been arguing about all along and how it doesn't work. Ergo, it debunks the geometric model.
Yeah, I think the fact that it sounds complicated Euclidean geometry when you hear it, it sounds, ooh, that's a bit fancy. But the basis of it are so simple that it's easy to understand as long as you can detach yourself from the thought that it's complicated. And that's the problem that you have to deal with. You know, that people think it's far more complicated than it actually is.
That's because we're told that. So if you imagine the higher level fundies that oppose us, their ad hom of choice, opening ad hom often, is you don't understand geometry. That's what they'll tell you, making you perceive a complicated issue when they're describing it in the complicated manner that they do when it's done through the curve calculator. I don't know if it's intentionally complicated, but certainly the layout is designed to bamboozle people who are amateurs.
Yeah. Well, when you take it down to the simple fact that, last year, me and the lad, we went to do the Bedford level test so we sat on the canal with the camera out, and I'm thinking, because I've got a bit of a building background, so I come from a surveyor's type view on it, and I'm thinking, what the canal is a horizontal water level. It is a water level. So it confused me as to what exactly was going on and what, like how. So I then started thinking, well, I could actually measure this. I mean, people are just doing it by looking and visually citing stuff. And I thought I could measure this. And if I go up there and measure a level all the way along and drop it back down to the water level, and then I thought, oh, what would I be doing then? Would I be checking that the water level is in fact horizontal?
Yes, and the tools that you'd use to do it, what would the tools that you use to do it involve?
Well, I would use a water level.
Right.
Yeah.
Right. The whole thing is kind of pointless, and I completely agree with you. Every time somebody's done it, I'm like, well, what are you going to do to measure this? What are you going to use to establish it? What tools have you got? What the level?
Have you seen the way I set up my water level test, though?
No, talk me through it.
Well, you know what a water level is? It's just a massive tube with two vials on the top that you fill up with water, and it will establish a horizontal plane.
You showed us an image of it last time you did a it might not have been you, actually. It might have been somebody else. But nevertheless, yes, we've had that image on screen, although I don't have it to hand.
Okay, so if you imagine one at one end of a canal and one at the other end of the canal, and you put it in the canal, and then you lift it up a bit. So the vials will be showing at either end of the canal whatever distance above the water level in the canal. Let's say 5 inches. Now, if you was to get another water level or 2 more water levels and go from the outside but go towards the center with your water level, then the water levels within the thing would have to be horizontal, because that's what a water level does. It establishes a horizontal plane. But if the center bit was to rise, then you would see that within the 2 inside water levels. I have actually set it out as a test, and I've drawn it out a fair few times. Can I give you a picture of one? If I can try and find one. I should have come a bit more prepared.
No, that's fine. Don't panic about it. If you want to dig out a picture, then feel free. But verbally, it's you're doing an exceptionally good job. Don't worry.
Can you understand that? You know, that the difference would, if the water level were to curve, then there would have to be a difference within the center of where the water is and the outsides. Would you agree that you know, in order to judge a curvature, there would have to be a difference within the horizontal plane that is established through a water level?
Sure. What you're saying is, if you've got a starting point at one end of the canal and another, we'll call it also a starting point at the other end of the canal, and they're both showing as level at each point, to establish a curve, you've got to have it be raised up in the middle.
Yes. Yeah, because initially when I started asking the ballers on which model would they choose a rise to a fall to end up as a level point, or is it a constant fall away with the water level? So it already starts to sound really weird when you start asking the ballers this question: what happens to the water level from the position they are?
Well, I can answer that mathematically speaking. So each observation point would be started with the assumption that you're at the top of the sphere and you're looking down towards your, you know, horizon point, wherever that may be, because it's falling away from you based on you being at the top of the sphere. Now, their mathematics would automatically fall apart because you have to do both at starting point. That's why I call them both starting points. So starting point at the one end of the canal, you start measuring out how much the Earth is falling away from you, because they're actually measuring perspective, towards the centre point. If that's what you're going to measure from the other end, when you have another starting point, measuring how much the Earth is curving away from you. So they're both curving away from you, both starting points curving down towards the middle. So you should have a downward drop towards the centre of the canal based on both measurements. Now, obviously, their measurements are only going to be done in isolation, one particular observation point, not two simultaneously. They're both starting points. So you'll never end up with a situation where their mathematics is being utilised in that manner. You just start the maths fresh from both. Well, it's falling away from one side. Now let's scratch that and start again. Well, it's falling away from the other side, 8 inches per mile squared.
Yeah, you're always going downhill on water.
Yeah, it's just the effect of perspective. So at the beginning of this discussion from yourself, you've got the picture of the wind turbines when Ranty detailed this 3 years ago now. And he's got the wind turbines falling away with perspective. Always claimed to be Earth curve, measurable in the maths as the 8 inches per mile squared, presumed Earth curve falling away in the form of those turbines falling away with perspective. And then you put them side on, and they're all absolutely perfectly level. But the mathematics is purely a hijacking of perspective effects to replace that with the claim of a physical geometric Earth curve obstruction called the horizon, and a drop from your position at 8 inches per mile squared in rough mathematics.
The water level takes all of that away from them, takes the sight away. You don't need a line of sight with the water level.
No,
between the 2 points.
No, it cocks everything up though, because you're speaking with a level of redundancy that fundies will nod along with, and with us, it's just like you've been saying the whole time. Well, this doesn't make any sense. I'm going to establish whether or not the water level is level. It's like it's water. It's a canal.
Yeah, can you see the pictures I've put in the thing? Because it's quite interesting, because I've did my water level test and showed them horizontal, but these pictures have been done by a so-called maths teacher. So she's mapped it onto a curve to show how she imagines it to work. So she's geometrically shown us what her idea is, which I've pointed out proves that the verticals and the horizontals within Euclidean geometry don't work. So she's basically proved through geometry that there's only one viable option for this particular water level test geometrically. Why it's one of my proofs that the water level is horizontal. I mean, I wouldn't say it's a proof if I was absolutely certain, if I wasn't absolutely certain that it's an actual proof. This test could be done, but there'd be no point in doing it because all you'd prove is that water level is horizontal.
Which we should appreciate at a fundamental level when you watch, if you're standing on a riverbank and you're looking down the river or the canal in this instance, as is probably the best example, several miles, I think it's 5 miles, non-stop straight. Nevertheless, when you're looking down that water, you'll see the water below your feet, if you're standing on the edge of the canal, rising up to the horizon. Not falling away, rising up with perspective. And the trees that are above you, if there's a row of trees, we'll assume there is in this particular example, going down the side of the canal bank, well, they're going to get smaller, the ones that are above you, and come down towards the horizon. All effects of perspective. But the things getting smaller and smaller and smaller into the distance are just alleged by the way of them falling away according to their mathematics as being on the side of a sphere edge when you look at it like we're looking at this picture that you've given us. You know, you're looking side on. You're never looking down it. It's always Muppet vision.
Hold on. Are you saying perspective is a real thing and not something flat earthers made up?
Yeah, it's not
not something that's just in art class, like I was told.
No, when we were pointing this out to them 2 or 3 years ago in the Isle of Man discussion, we were told this is a geometric calculation. You don't need perspective in this. And then they'd hand wave it by calling it flurfspective. Now we get told when we absolutely pummel people like AB Science, well, I was talking about optics. It's like, well, your maths isn't, moron.
It's the geometry, isn't it?
Yeah, it's geometric. Or it should be. Apparent horizon. Yeah, no, not geometric then, morons. Hello.
It takes them into a strange place, this. You know, the idea that the horizontal and vertical, like, what they have to do is we take a normal plumb bob and a level tool, the water level, as a horizontal and a vertical, and know that they are perpendicular. But in their idea of their model of some fantasy geometry that they start playing, they swap that. The vertical then becomes a radius, and a horizontal becomes a tangent to a surface of some unknown origin R value that they magic out of nowhere, but then still play the normal vertical horizontal rules. Can you see that picture that 10th put in?
Right, I've got 10th man's image. Well, nearly there, yep.
Yeah. Well, yeah, this goes back to the geometry problem that they have. I wanted to point out that you know, the radius that you have within Euclidean geometries defined from a center point and then the radius. And then the outer point of the radius on their model is a horizontal, which is fantastic. That when you think at the end of R, that's what they have, a horizontal plane surface.
One of you read out what's on screen.
Oh, that's the wiki picture, isn't it? So, yeah, within wiki, they have on the spherical model. So their spherical model that they have has a horizontal that comes out from the pole. And also a horizontal that comes from the equator. So they have intersecting horizontals that are perpendicular. Now, I don't know. Not in any sort of geometry that I think of, but I mean, that's actually what it says. I don't understand which geometry that is possible on.
Globe geometry. Now debunked.
Yeah, it doesn't. It's not like a geometry can give you a proof of how it works. That's the whole point of geometry. It gives you proofs, or it proves itself within everything other than the axioms is provable within geometry, or within Euclidean geometry anyway. So this, I don't understand the geometry which enables them to have a horizontal that intersects a horizontal, because I don't know, in my reality view of the world, a vertical and a horizontal, they are real terms, you know, real life words that are used not necessarily through geometry on the paper. The geometry would explain what a perpendicular is, and how the straight lines work through the geometry, whereas a vertical and a horizontal are real life terms, definable by a plumb line and a level. So I can't see how they can use geometry that doesn't fit them terms. That's basically where we're getting to. But when you ask a baller something like this, there's something strange that happens, because they automatically say, "Oh yeah, that's what happens," but they have no way to prove it. They don't understand the proofs that geometry gives you. Leaves them in a very strange situation of how do you prove that?
You don't. You
No,
described it in
they
the pre-show.
can't.
They assume the radius value and then apply it to an observation, but they bastardize what's actually being calculated by putting it in Muppet Vision, like this, side on. It should have been
Well, I'd
spotted.
say
It should have been spotted when they started refracting things using the non-geometric values. That should have been the point that the alarm bells went off. But like any smear over the top of a lie, initially people gobble it up. And that's what we did, you know. Oh, right, so you're using your bog standard geometry, and you're drawing a straight line to a physical obstruction, and then what's that? You say the targets we're looking at, they're all refracted up to this point where you've got this physical geometry with straight lines. You should have spotted it then.
it's surveyors use Euclidean geometry. Everybody uses Euclidean geometry. Whenever you measure a distance to anywhere, you would assume a right-angled triangle in order to, then you can work trigonometry for your angles and all the things like that. So you have to have the vertical and the horizontal of the bottom of the triangle being straight lines and perpendicular to each other to form a right-angled triangle. So any measurement that you ever make is performed when using Euclidean geometry. Now, I'm not aware of any way that they could use a measurement within Euclidean geometry in order to disprove the geometry itself, because you would have to disprove that vertical and horizontal are perpendicular to each other.
In other words, they're working against the axioms that the maths they're using is based on.
Yeah, they just completely forget about the rules of the geometry that they pretend that they use.
Shout out to Cleary, who says, the geometric horizon is not geological.
Yeah, big shout out to the Black Swan, because the Black Swan has exposed this fundamental problem that they have with the geometry. That just the word that once they've realized they've lost the geometric horizon, then it's time to re-look at the actual geometry that you're using. And you find that it's Euclidean. And everybody, please just have a look at it. It's a perfect system.
I like
Perfect
the ones
geometry.
The early adopters of the argument on the globe side didn't realise how the argument was structured and their requirement, as you put it, for a geometric horizon. Now, I've been screaming this down the mic for 3 months now. So, anyone who's familiar with the show will know I've been shouting, you require a geometric horizon. And it's very true. But the guys who are like, oh, we can solve this problem, it's refracted. And they don't realise how much pain they're causing their own model moving forward, not trying to figure out how to justify a geometric existence, but a non-geometric horizon, unlike the one in their model. And they think that they've got to win. It's like, no, what you've just done is shot yourself in the head, because this is your declaration that we don't have what you require anymore, and that's precisely what we declared when we exposed the black swan in the first instance. You only need one to debunk the geometry. Once it goes beyond the geometric limits, it'll never be geometric again. And everyone's like, nah, it's a dead swan, it doesn't matter, because they haven't paid attention to the actual argument. And then they go in headlong to try and debunk it and declare just how non-geometric it is, exactly as the argument was set out. And you're like, well, that's what the argument is. You don't have a geometric horizon, you just didn't read between the lines. You read the modus tollens argument and assumed that the first premise was wrong, based on your geometry. Oh, what, that's a straw man, we don't have your geometry. Oh, well, welcome to Flat Earth. But they don't get it. They think they're winning.
No, they just give up.
It's almost like they forgot that they used to debate with us about the physicality of whatever was making that boat or building or whatever disappear bottom up. That used to be the curve doing that. The physical hump or the bulge or whatever word you want to use to describe it, it was physical. It's always physical, according to them. So I don't know what happened.
Well, we're lucky.
Did you say they forgot what they were fighting for, Nathan?
Yeah, they forgot they were fighting for there being an earth curve obstruction. Like when they argued for this picture on screen now. They argued that the bottom of the island was missing because this physical line they claimed was a physical geometric horizon calculable in their geometric maths was obscuring the bottom of the island. Well, that's their model. That's what their model implies. But they drew a straight tangent to this point when inside of Profile, Muppet Vision, Orthographic View, where you see your side of your own head. Well, when they were doing that, they were using standard geometry to the geometric horizon because it's absolutely necessitated in a geometric model, and then utilising that geometry to give them their terrestrial refraction value, 7/6r, again utilising the r value that gives them the geometric horizon in the model. Well, we've only got one horizon. A horizon is the apparent position where the sky meets the ground, or in this case, the apparent position where the sky meets the ground. Well, no, bottom of the Isle of Man, and how much it's being obscured by that physical geometric horizon. And that's what they drew their straight line for a tangent to, while simultaneously claiming that that straight line tangent to a physical geometric horizon based on an r value also gave them a refractive value based on the r value and the geometry. So the entire thing collapsed upon itself when you point out that no, you don't have a physical geometric horizon anymore. And their defence to that is say, oh, we'd only see it if it was all the air was sucked out. You're like, no, you claim you see it based on your geometry. That's what you're claiming is obscuring the Isle of Man, claiming boats are going over. That's what you say the sun sets behind. That's the physicality of your sphere Earth that you think you're standing on, proven out by its physical geometry in your geometric maths and its geometric horizon. And then their reply to that, nah, we only see a refracted one. Oh, well then bye-bye globe geometry, moron. Welcome to Flat Earth.
Yeah. Yeah, that's what I was gonna say is they didn't forget about shit. All right. They realized very quickly how devastating the black swan horizon is. And therefore they immediately had no place else to go except for to claim optics. And now they're trying to dump optical refraction on top of terrestrial refraction to account for, black swan incidents.
Yeah, I would agree.
They didn't forget about a damn thing.
I would say
they're that intellectually dishonest.
Yeah, I'd agree with you. I would say that they didn't forget. what they're trying to do is Jedi mind trick everybody into thinking, yes, we have never argued that the geometric horizon was physical. We've never argued that, right? Like Rumpus and Brenda and all of them. That's what they're saying. We've never argued that. Well, really, because I've been here for a few arguments with that when you said the same thing. Luckily, Nathan tapes these things. they're on record. You morons arguing about how geometric your horizon is supposed to be.
I have a question concerning that, though, Chocolate. Beyond Brenda and Rumpus, has anybody else actually gone that far?
Yeah, loads of them. I've got them all documented. You've got Unorthodox doing it, you've got Kosho doing it, you've got AB Science doing it, you've got Simon Dan doing it. They're all doing it. They're all towing the same exact line. Yeah, the argument was carefully phrased, and their rebuttal was anticipated. Their rebuttal is to say we don't have a geometric horizon, you fools. And we laugh at them and go, haha, welcome to Flat Earth then. What's this one marked with an X? We haven't got two. No, we only see one. The one we see is based on this one. So not this one. So that one's the second one then. Well, no, we don't see it. No, you're damn right we don't. Welcome to Flat Earth.
Yeah, that's actually man, that is the best point. And the way you said it, it's like twisting the knife.
Yeah, you tell us just how much we don't see your geometric necessitated horizon when we've only got one of them. Your geometric horizon still described as the apparent position where the sky meets the ground now, isn't it? But it isn't the apparent position where the sky meets the ground. It's a second position that only exists in your model. It's not the horizon we see, like you tell us with a hand wave. We're going to start repeating your Jedi hand wave and just repeating it back in a slightly different tone. Oh, we don't expect to see the geometric horizon. Yeah, we don't expect to see a geometric horizon marked with an X labelled horizon in your model because we don't have one. That's correct. Welcome to Flat Earth.